Okay, good afternoon, everyone. Welcome to the first afternoon session that we have. We've got John from IntelliMagic. I'm going to hand over to John, ask him to unmute himself and share his screen. Got a great presentation coming up. If at the end you can all leave feedback, it'd be really appreciated. And John said he's happy for questions at any time. So if you can write your question out and post it in the chat, that'd be great. But if you have questions at the end, then we can come back to questions towards the end of the session. So over to you, John.
Okay, thank you very much, Nathan.
No problem.
Great. So I hope you guys can see my screen. Firstly, let me introduce myself. My name's John Tissick, as you can see from IntelliMagic. And I'm not standing in the parking area of our building. I'm at home, actually, in my home office. So I'd like to just quickly turn off my camera and start this presentation. So what I want to focus on today is basically the question, do I know my FICON infrastructure, how things are connected? And what I'd like to do is introduce the possibility of using SMF and RMF data in order to join the dots and see how the infrastructure is connected and what we can get out of SMF data. Okay, so the first thing I'd like to do is just have a quick overview what the FICON infrastructure is. And my focus is also on disk, but not tape and other things, but it is certainly expandable to other items as well. Okay, so an overview. And then I'd like to look at which SMF records are available and could be helpful and useful in building a picture of how things are interconnected. Once we look at the overview of the SMF records, then I'd like to get into the details of those SMF records and see what we can pick out of them in order to build our FICON infrastructure picture in this case. And my final point is, agenda point, is to look at the FICON topology and what we can get out of this data visually. And I'd like to just quickly do a little bit of interactive work with a web reporter on our software, just so you can see what kind of information you can get out of this kind of data in this kind of visualization. Okay, so just quickly, IntelliMagic, a little bit about the company that I work for. We've been working in ZOS, MVS, OS390, ZOps analytics for quite a while. So we have a lot of experience. We have a lot of smart people developing software, analyzing data, and helping us understand what happens in our Z infrastructure, in our Z environment. So we do have lots of customers, quite happy customers, I'd like to say. And we do have a global presence. Our headquarters are based in the Netherlands, in a beautiful university city called Leiden. And we have headquarters in the United States, in Texas, and also in the German area, in the Munich area, looking after the German-speaking countries. As you can probably see on the top line, it says IntelliMagic, an IBM company. That's a very recent change. So we are now part of IBM, and we're all looking forward to seeing how things move together and how we can enhance what we do and make our customers happy. So let's look at the introduction, FICON infrastructure, an overview. So in my very, very simple example here, I'm looking at two CACs on the top left and right. We're looking at FICON switches and the connection with FICON channels to disks, different kinds of disks. And of course, as I said, there are tapes and other things there as well. And typically in our infrastructure today, even in this simple example, we do have multiple locations and we have inter-switch links connecting the FICON switches between these two locations. So this is just a simple example. Visually, it's nice to see this. We can maybe put a name on a disk or on a CAC and understand where it's located and what relevance it is to our business. So a visual review of our infrastructure is actually quite useful and quite important. So historically, IBM has had the Hardware Configuration Manager, HCM, which you could not only use to make your define your control units and channels in your infrastructure, but you could visually, graphically look at your infrastructure. My simple example here shows that this is difficult to actually see information here at a top level. You can drill down and isolate certain areas, but the visualization from HCM wasn't really very useful. And this is an extremely small example I have here. So why would we want to look at our infrastructure visually? Okay, firstly, we believe that we can use SMF data, which is typically looked at as having a performance focus. But we're looking at the ability of using SMF data for configuration information. And if we have the right kind of SMF records, then we can join the dots and actually create a view of our infrastructure. So what do we need? Well, firstly, let me just talk about the difference between logical and physical entities. That's important. There are things that our ZOS LPAR understands. Logical entities is the term I'm using. For example, a channel path identifier, the chipid, or a device number, or a logical control unit. So these are things that are important and visually viewable from our LPARs. But there are physical entities as well, and they're relevant to the hardware and the physical infrastructure. So something like the physical channel path identifier, the PCHID, which actually defines the physical channel from the KEC that is being used. That's an important thing when you're defining your infrastructure, to know which physical channel it is, which card it's on, and things like that. For a disk system, the subsystem identifier, it's a physical entity which is important to understand and to define in the disk systems, and the disk adapters, things like that. So all I'm trying to do here is explain that there are physical and logical entities. And that's important to understand when we look at the data we're looking at. Is that field in SMF representing a logical entity or a physical entity? Okay, so what can we get from a visualization of our FICON infrastructure? Well, firstly, as I said initially, we could look at our locations of maybe a primary and a secondary site and the interconnection between these sites. If we look at the FICON visualization, we could look at maybe the FICON level. We're expecting that all of our FICON channels are running at 16 gig. Down to the disk system, we go through FICON switches. Are we actually connected with 8 gigabit and not with 16 gigabit, not with 8 gigabit, for example? Is our expectation, the way we've defined it, actually the reality? And the reality is in the SMF record. Unbalanced FICON traffic. So we have maybe 8 FICON links defined to our disk system through switches. Are they all having approximately the same amount of throughput? Are they balanced? It's a very important issue when it comes to utilization of not only the links, but actually the end devices, the disks, for example, the disk adapters. We don't want to have 2 disk adapters overused and 6 not used to the same level. Switch interconnection, by that I mean the interswitch links, for example. We're expecting, and the way we define things in a FICON infrastructure is that we can get to the disks from our LPARs and KECs across these interswitch links. For data center swaps, availability, very, very important issues. LPAR connectivity, again, are all of our LPARs connected in the same manner to our disk systems or tapes? Number of FICON channels, speed of the FICON channels. So the various things that are important that we can actually get from a visualization. So now we get to the interesting stuff. Which SMF records can we use to get at this information? So here are SMF records produced by RMF or by CMF. And on the left, I've listed the SMF record number and the subtype, and then the type of record, CPU, for example, for SMF 70.1, and then a short description. So that second column, CPU channel, ESS IOQ, that probably matches quite well with the RMF command needed to gather that data. And on the right, you see some of the information that's provided in that record. And this is really just a subset. For example, the cache record does give us cache information, but it gives us RAID group information, adapter information, lots of good things at the device level as well, okay? So these are very important records that RMF creates for us. Again, not only performance information, but also configuration information. And I'd like to introduce this record to you, which is a non-RMF CMF record. It's called the Link Diagnostics. SMF 124, subtype 1 is what I'm looking at. It's a very, very interesting record because it provides, for every LPAR per FICON channel, information about the channel, i.e. the chiplet, the switch, the speed of the channel, the control unit entry and exit ports. And that's the information that we're using for our configuration. But in addition, there's a lot more information at the FICON channel at the link level about the link speed, about the temperature, transmit, receive power, buffer credits, things like that. I'm not going to get into that, but this is a very interesting record that you should be looking at potentially if you're interested in your FICON interconnected devices. Sometimes SMF records can be overwhelming by the number of records. This record is very good as far as I'm concerned. 1 per LPAR. It only contains information on these categories for the FICON channels, which means it does not take a lot of room in your structure or in your man data set. Now I'm concentrating on subtype 1. There are other subtypes for encryption information at the link level, okay? But let's not look at that right now. So I can highly recommend take a look at this, and it is automatically created. You may just need to look at your SMF parameter to SMF palms to make sure you're not suppressing it, okay? Okay, so that was the overview. Now we're getting into some of the details of the SMF data. So I'd like to go through these RMF CMF records and look at the bits that are important for our configuration information. Okay, so this is the CPU record where you'll see I've highlighted in green some of the field names and then some of the contents that are important. And this is just from one of our small LPARs here. The red RIJN is the name of the LPAR, and you see the serial number, things like that. So from the CPU record, or the subtype, this is the kind of information we can get out of it. The serial number of the KEC. The sysplex is not visible in the formatted report from RMF, but it's there in the SMF record. LPAR partition name. So just some general information about the LPAR. SMF 73, the channel record. Again, we have interesting information there. And now we have FICON or also OSA channel information, okay? For example, if I just go to the next screen, you'll see that we have for the chiplet, which is a logical entity, remember I said that, we have something called the FICON speed. And in the report, there's something called G for generation, and every FICON channel is assigned a generation, and depending on whether it's been auto-negotiated down to a slower speed, that'll change. So you can take a look at the IBM support site, and you'll find hopefully information about the generation that you're running and the possible options. So that's very important for the FICON channel. What is it supposed to be running at, and what is it running at, okay? And of course, the LPAR is in this record, and also the channel subsystem ID. So then we get to the device information. So the device information, I have an example here for one particular device. I've highlighted it in red. So it's device 6001, and it's my name, John01. And we have a logical control unit, okay? Logical, not physical control unit. So what we have in that SMF record, as I said, the device number, which has the subchannel set in front of it as a single byte. Okay, so that's information at the device level now in that SMF record. The cache statistics, now we're looking at an example of a disk where you can see the serial number highlighted in red, and we have something called a control unit ID, which in this case is 6008, and next to that a subsystem ID, 6100, and again you'll see my sample volume device in that list. So the control unit ID is an important field, and I have a later slide where I'll talk a little bit more about the different control unit values we see sometimes in our reports and what they mean. Okay, that's important. Subsystem identifier, we'll also have a look at what that is, and that's a definition that is needed and defined in your disk systems to clearly define the association with the control unit and then the devices. So we're looking now at the FICON switch information. So this is very important for us because typically in an installation, we have our CEX with FICON channels attached to FICON switches or FICON directors, and then the control units, disk tape, etc., and potentially also ISL links to a remote site. So what we're seeing here is the port addresses on the FICON switch, and then some information about the unit, the control unit in this case, or the chiplet, and then information about the chiplet number and the serial number of the CEC, or for the control unit, the actual adapter information, or sorry, the control unit and the serial number. Okay. So the FICON switch or FICON director gives us information about the configuration of the import, entry, and exit ports. Okay. So we have to be careful when we look at this record. The switch device is a logical switch number, and the switch ID is not always available. So if you have a large installation with cascaded switches, the switch ID is probably not going to be available. Now, I did mention the unit, maybe the chiplet or the control unit. But there are some restrictions as to what you can see. And we'll get to that in a second as well. Same as the unit, the serial number, okay? So for these fields, for the unit, the control unit, well, that is available, and the target switch is available. But if the port we're looking at on the FICON switch or the FICON director, if that's a entry port for a chiplet, it's only going to have information about the unit type for the LPAR that's cutting that record. It's important to understand. Okay, so unfortunately, that piece of information is only available from that originating LPAR. So for the ID field, the chiplet, also not always available. It depends on which LPAR is cutting it and where it's getting the data from. Yeah. So the FICON director information, unfortunately, sometimes is not filled with all the information we would like. Now on the bottom, I have an additional line which refers to the port number and the port address. Quite often, they are the same, but not always. So you have to be aware and look at both of these fields in SMF, just to verify that in your case that you are talking about the actual port number or port address that you're expecting, okay? So another interesting record for disk systems is the link statistics. So it has various things in it about the attached RAID groups, for example. But I'm only looking at the link information here. So for this particular disk system, I can see the adapters. That's the SAID and the type of connection there and the speed. So let me just go to the next slide. And here I describe a little bit about what we're looking at there. Adapter type, etc. So another SMF record we're looking at is the IO queuing activity. Now, in this example, we're looking at a logical control unit. We have a control unit information as well. And then the chiplet paths being used with, of course, performance information on this chart as well. But as I said, our focus is on configuration right now. So this is the kind of information we see in that record. And it's important to distinguish between the logical and the physical information that we're looking at this. Okay, so a word on control units. I've mentioned logical control unit a couple of times in control unit. So the logical control unit is typically what we're going to see in reports, in ZOS reports. It's created when you activate your IO definition. And depending on which IO definition is activated on the LPAR, it may be different, the logical control unit, but it's actually still the same physical control unit in the back end, okay? Be aware of that. CU control unit, okay? We're referring to that as the hardware control unit, and we define that in our HCD when we define our installation. So in the cache statistics, there's something called a control unit identifier. This is interesting because, yes, it is a control unit, but if you look at that report, you may see something like a control unit identifier 6014, because the definition is that this control unit identifier takes on the value of the first device that's online. So this could be a little bit confusing, so be careful with that, okay? And of course, then is the subsystem identifier, and that's defined in the disk hardware. And for us, that's clearly what we're looking at in the disk environment that is a control unit entity, if I can use that term. That must be unique for the ZOS LPAR, yeah? So that's something about control units. If we look at our hardware configuration definition, here's an example for control unit 6000, 6100, etc. So there are 8 control units here. It's an IBM disk system, and you can see the CSS and things like that. So for those of you who do configuration definition information, this is something you're very common with. What we don't see very often is the IOCP that you can get produced by HCD. And here you'll see maybe the old-fashioned way of looking at a control unit, 6000, with the CSS 0 and the 4 channels, FICON channels. I've highlighted number 30 just as an example. And then the links. If we look at the links, I've highlighted 400B. And we'll get to what the 40 means and what the 0B means as well in a second. So those are the RMF records that contain a lot of good information for us. And now we get to the SMF 124 subtype 1 link diagnostics. It CAMs print, yes, we can see it in hex, but it really doesn't help us much. So if we look at this in a slightly more formatted form, I'm just using homegrown recs, then what we can see here, and I've highlighted it firstly in red for the LPAR on the extreme left, and then channel port, then channel 30, FICON director, and then 0120. That's the actual physical channel identifier, the PCHID, which you don't see normally from our ZOS systems. Very important piece of information. That's the physical channel entity on the KEC. Let's call it that, not the logical chiplet. Second line, entry link in green, 4001. When we look at that, the 40 is our logical FICON switch, switch 40, and 01 is the entry point. So that's port 01. Second, or rather the line beneath that, exit link 40, logical switch 0B. Okay, so that's the exit port. And the SMF 124.1, the link diagnostic, gives us information about the worldwide port name, which I've highlighted in red there, for all of those entities. And we can see the control unit port 0330. That's the adapter. So this record gives us a lot of good information as to our FICON connection with a switch, not only the logical switch, but which entry port, which exit port, which control unit, which pitchet, things like that. So really good information for the configuration aspect of this record that we can use. I've done a couple of displays in ZOS in the console just so we could see maybe some of this information as well. And I've highlighted in red those fields that I've selected in the previous records and also in the previous RMF reports. Just so you can see, I'm using chipper 30 as an example. Link address is logical FICON switch 40, entry port 01, exit port 0B, etc. Okay, so we can look at the control unit display and also a device sample. So that's ZOS output. If we log on to our actual disk system, we can see things like our devices that we've created. And then you see on the extreme right-hand side, ID 00 and SSID 6100. So this is where we define exactly the SSID that we will see when we IPL our systems and it comes online, which must be unique. And that information we see in various RMF records as well. Okay, so now we've looked at the tough stuff, the SMF records and also the link diagnostic information. So let's go to FICON topology. So now we can actually take that information and put it together. Now this is a high-level visual view from a very small environment. This is our environment. And what I'd like to do is just quickly stop sharing the screen and go onto our web browser where we can look at some of this information interactively to give you an idea of what kind of information is available and how you can use it, okay? So let me just stop sharing. And let me just share my web reporter. Here we are, okay. So let me just have a quick look at this. So the first thing we're looking at the first thing we're looking at here is basically just the FICON Direct data in a tabular format. Logical switch 40 is what we were talking about. Port, input port, output port, for example. This is our KEC here as an input port. This is an output port. This is a Hitachi box, okay? So this is the kind of data that we formatted from the FICON switch. So when we go to FICON topology, this is what we're just looking at here. So from the SMF records, we've extracted things like the sysplex name and the KEC name, the CSS, and the FICON director, and the disk systems beneath them. And as you can see, when I move the cursor, I can actually see things like how many channels are used. But let's get into some of the more interesting details by zooming into our FICON switch. Now, as I said, this is a very small environment. But now, based on the SMF data that we've been looking at, we can see our KEC here, and we can see our channels, our FICON channel, and our pitchet as well. So this is the physical channel on the KEC, and we can see it's 16 gig. So that example that I was looking at, I believe was channel 30, and we can see that it's connected to logical switch 40, and the entry port is 01, which has two exit ports, 0B and 10. Okay, so by moving through interactively through our FICON topology, we can look at things like, well, how are they connected down to the actual, what we call the host adapter, the interface adapter, and with which speed. And we can see, for example, that this channel is 16 gigabyte, but when it's connected to this particular disk system here, or maybe let's choose this one here, it's starting out as 16, coming out of the FICON director, and it's connected to a port which only supports 8 gigabytes. So we can get information about our infrastructure and potentially try to isolate where things aren't defined correctly. Okay, so there's a lot of information in those records. And let me just stop sharing and go back to the PowerPoint. Okay. Okay, so this is our FICON topology. Let me just quickly go through what I've gone through by looking at the individual levels of the KEC, how many channels, what kind of channels attached to a particular chiplet, what speed of the channel attached to the P chip, to the physical channel path ID, and then the entry port to the switch and its speed, and the exit port and its speed, and of course then the adapter. So there's a lot of interesting information obtained via SMF records. Auto negotiation, that's my term for, our term for a FICON channel which is starting out as being 16 gigabit capable, but being connected maybe to something which is slower, i.e. 8 gigabit. That may be a desired architectural limitation. That could be a configuration issue. We need to sort that out if that happens in our environment. Now, this is an example of a very simple FICON infrastructure, but it can get much, much more complicated. We can see many different sysplexes with LPARs, different KECs, a lot of interconnections between the switches via ISO links, a lot of tapes and disks, and interactively being able to drill down to the data allows us to look at that information that we've obtained through the SMF records. Okay, so this was hopefully an introduction into topology and FICON infrastructure, and also what kind of information is available in SMF records. So this is the end of my presentation. I hope that there was interesting information for you. And if there are questions, please feel free to ask questions, and I'll see if I can answer them right now.
Thank you, John. That was an excellent presentation. Whilst everyone has a chance to think of some questions for you, I will just post in the chat for everyone a link to feedback. If you can give feedback, it's really helpful. It's really appreciated. It helps us to organize the sessions, and likewise on the presentation, you'll be able to find the session code. We have a question from Brett Jukes. John, if you can see that in the chat.
Let me just go to the chat.
No problem.
Is it possible to share that RESC to convert the hex into words? I suspect I can share that. Let me just ask my my colleagues, but I don't think that's a problem. So if you can just send me an email, and I can then get back to you on that. Is that okay?
John, before we move on to Martin Packer's question, are you able to pop your email address in the chat, just so that if anybody doesn't have it, then they can follow up afterwards with any questions they come up with afterwards?
And there's my email address.
Okay.
So just send questions or send me that request and I'll get back to you, okay?
And then we have a question from Martin Packer. You can see that one.
Do I find value in reporting on SAPs and IOPs? So maybe Martin, you could expand interactively what you mean by that question. By SAPs, you mean?
Tell you what, Martin, I can unmute you if
Yes, that would be good.
If that helps. I can find the button. Looking for you on the list of participants, Martin. Mr. Packer. but you
Okay.
should be unmuted, Martin.
All right, good afternoon.
Hi,
Afternoon.
Martin.
Hey, John. So yeah, IOPs are just for people who don't know, IOPs, SAPs are Z cores that have a specific job in handling IO on the mainframe and look after things like channels. And they're documented actually, I think in 78 subtype 3 again, and they will show things like skew, and they will actually show SMT status and stuff like that. And I'm not sure I find them hugely valuable, but I mentioned them really more for completeness of the IO picture. So it's a genuine question actually, John, whether you find significant value in them or not really.
Well, I do look at the IOPs when, for example, a customer has a very, very high workload. In the old days with XRC mirroring, there was potentially a recommendation from IBM to look at your IOPs and to convert one of your processors to an IP processor. You could do that on the KEC. Now, today, the IOPs are very, very rarely overused. So, we can look at the IOP utilizations, and we're talking about 10, 15, 20% IOP busy. What we sometimes see, though, are control unit retries. And the IOP is being used not only to service IOs to a disk or tape, but also to coupling facilities. And sometimes we actually do see interesting information on the coupling links and the IOP interaction. So yes, I think it is interesting to look at the IOPs, but they're not very often problematic, if I can use that terminology. Yeah.
I think I agree with you, actually. I mean, there are functions that are beginning to use them a bit more, but yeah, I agree with you. It's just I thought, hang on a moment, that's the one thing you haven't talked about, and
That's true.
The answer is because it's not that interesting.
Exactly. Yeah. Yeah. We have had cases of a lot of retries, and if you look at all your IO processors, and you buy a KEC and it comes with a certain number of them, sometimes you find 2 of them burning and the rest not. And then often when you look down, it's the coupling facility links. So we do have sometimes those kinds of interesting observations.
Yeah, I mean, I normally, to be honest, what I do is I actually document how many a customer's got on the machine. Because for people who don't know, you get a standard set of them, but you can buy additional ones if you think your workload is particularly warranting it. So it's just nice to know whether a customer did that from my point of view.
Exactly. So if we look at the information from the 70 record, 70.1, that's where you'll see your IOPs that are defined on your KEC. Yeah.
No, not in 70 subtype 1, 78 subtype 2 gives it actually.
Let me just...
I know that the hard way. I have to pull them together in my reporting. So anyway.
You sure? Okay, I have it in the 70.1s, but yeah, that's okay.
I mean 78 subtype 2, that's virtual storage. I mean 78 subtype 3. Anyway, all right. Thanks.
Okay.
Excellent. So it doesn't appear that we have any other questions, so we'll leave it there. John's email is on the screen, and again, for just a reminder about feedback. Thank you, John. It's a great session. Really appreciate it, and I hope to see everybody back for our next session on the stream at 3 p.m. And we'll leave it there. Thank you, everyone. Thank you, John.
Okay, thanks, guys. Bye-bye.
Bye.